Alright, for this first review problem in a couple of sentences, I need to fix that. Describe why mathematical induction is important and the circumstances under which it can be used. Mathematical induction is a technique that we use to prove patterns, usually patterns involving integers. So for example, one possible pattern that we've seen before is check that 1 squared plus 2 squared through n squared is equal to n times n plus 1 times 2n plus 1 over 6. Now this is a pattern, and it's fairly easy to check that this works for the first few numbers. So 1 squared is indeed equal to 1 times 2 times 3 over 6. And if I take the first two numbers, 1 squared plus 2 squared is equal to 2 times 3 times 5 over 6. So if I cancel here, that's 6's cancel, leaving me 5 on this side and also 5 on the other side. And if I go one more term, then on this side, if I plug in n equals 3, I get 3 times 4 times 7 over 6. So I get 12 over 6 is 2 times 7 makes 14, and that's 5, the same thing as 5 plus 9. So this is a pattern that looks like that it works, but I've only checked it for the first 3 numbers. Mathematical induction is a technique that will allow me to prove that this pattern is indeed true for all integers without directly checking it for every single value of n. And the classic counterexample is the assumption or the conjecture that n squared minus n plus 41 is prime. Now this actually is a false statement, and this is for all integers n. This is actually false. However, it is true that if I plug in 1, if I plug in 2, in fact if I plug in anything up to 40, the first 40 examples are all prime. So I could test the first few examples, and I could be at it for the better part of an hour to check to see if these numbers are prime, and they would all check out. However, if I plug in 41, that's going to be 41 squared minus 41 plus 41, and that's 41 squared, which is clearly not prime because that's 41 times 41. So all this to say that just checking the first few numbers is not a proof. And here I'm checking the first 40 examples, and this works for the first 40, but for the 41st it fails. And I could check this one over here for the first 40 also, and on the left, and this would also work. But mathematical induction is a technique that allows me to prove statements for all integers and not just for the first few examples.